courses I'm not aware of. So for maths one, I can just tell you, prepare week 5 to 8 very nicely. Okay. So at
Okay,
most
sir.
of the questions, yeah, 95%, even whole questions can come from week 5 to 8. Okay. Yeah, if one single question or two questions comes, you can't challenge it later, but that's why I'm saying you most of the questions will be from week 5 to 8. Okay.
Okay, sir.
Yeah.
Thank you, sir.
Hmm. So will be altogether some questions, 11, 12 questions will be there, but if you just add all the subparts and all, it will be going to 18, 19, even 20. But those subparts will be very small. Can be some true and false also. So there can be some 5, 6 true or false also. Okay. So that's why the number of the questions can be high. But if you just count it individually, it will not be crossing some 12, 13 questions. Okay.
Okay, sir.
Yeah. Anything else from quiz or any, I guess the graded assignment submission is done for week 7, right? The deadline is passed, I guess.
Yes, sir.
Okay, what's the deadline for week 8?
So it's 31 July.
31st. Okay.
31st.
Hmm. So we have scheduled the revision session also. If you could see the revision session schedule also has been scheduled, I guess. That's there on. So today we'll go through the summary part. I'll just give you an idea about the week 8. That's not much to discuss, but I'll just give you an idea about the limit, continuity, differentiability, and some of the rules, some of the nice method to solve to calculate the limits. Okay, there can be a chunk of questions from this portion where you have to calculate the limit of some functions, and then you have to check for the continuity, differentiability, all the stuffs. Okay,
Yes, yeah.
yeah. So the session that has been scheduled is one is today. The next one is on the Sunday, and from Sunday you'll be having continue 5, 6 sessions, 8 to 10. Okay. 29th we'll be having the last session for week 8. One Hindi session will be there on 30th, and then from 31st we'll be having revision session, 31st and 1st, and then second of August will be the mock discussion, mock paper discussion. So it'll be altogether 5, 6 sessions left before the quiz. Okay.
Okay, sir.
Yeah. So okay, let's start. I guess not much people will be joining. I'll just start
After
with
the
PQ.
person start sleeping, I think.
Yeah, I guess yes. No problem. So we'll start with this week 8. I guess till now you have already got an idea regarding the how to know regarding the for any sequences to know the limit exists or whether the that sequence converges, diverges, all those steps you already know. So in the exam also you'll be getting some questions for the sequence. So sequence can be given and then you can be asked regarding whether it converges, and if it converges, what's the value? Like what's the limit? Okay, if you start increasing the value of n for a sequence, okay. So there can be some two, three questions from those limits also, and there can be some two, three questions from the limit where the function is been given, and then you have to calculate whether the limit exists, and if it exists, what's the value? Basically, they'll be asking you the limit. So whatever the
Yes,
questions
sir.
in the question in the exam will be given, mostly the limit will be existing. If they're asking specifically whether the limit exists or not, okay. If they're not asking, they're just asking to calculate the limit, that means the limit already exists. Okay, you just have to calculate with some of the method. Okay, the one method I'll discuss is L'Hopital's rule, or mostly people call it El Hospital or L'Hopital's. Okay, that is the one of the best method that you can solve with, or we can go with the basic approach also. So that also can help you. So let's start discussing about the limit. I'll just share my screen. Are you able to hear me right? The voice is clear, audible, able to hear it right?
You are audible, sir.
Yes, sir,
Okay.
you're audible.
Okay. So first thing first, so the sequences and all has been discussed. I'll just go through for any function. You already know that at any function fx, for any function fx at some particular point a, okay. So at any function fx, they're coming from left hand side and right hand side, okay. So let's, for example, there is some function fx, and if you are coming from, let's for example, x tends to, let's for example, 0 plus, to the left hand side, this is left hand side and this is right hand side. If you can see that for any function fx, if you have to just check whether the limit exists or not at some particular point 0. So the most important part is you don't have to worry about the exact value at that particular point, okay. So the limit at some point 0, that means we're just seeing the value surrounding 0, okay, not at exactly 0. Like even though if at 0 the value is defined already, then it's fine, you can directly say that the function value at 0 is whatever the function value is coming. But if you have been asked for any function where that particular point the function is not defined, or this is an indeterminate form, so what you have to do is you have to just check whether in the neighboring of that particular value the value exists or not, okay. So there's a difference between, if you're just checking putting the value exactly at that particular point, and if you're not getting the value, you can't say directly that the limit doesn't exist. You have to check it neighboring to that. So 0 plus and 0 minus you have to check. And if you're checking those two values in the neighboring, from one coming from, okay, so I guess written the wrong thing. So this is 0 minus and this is 0 plus. Okay, 0 minus and this is 0 plus. And then this L. So the first part is if you are coming from the left hand side, and the second part is you are coming from the right hand side. So for any function, this is fx, and you have to check at, let's for example, at this particular a, okay. So let's for example at this particular, at exactly a, the function is the value you don't know, or maybe it's like in some independent form. But and if you are checking in a minus will be somewhat nearby to that a in the left hand side, and the a plus will be somewhat in the right hand side, okay. And if the value, if a minus that you have calculated and a plus that you have calculated both are same, then you can say that the limit exists at that particular point fa, okay. Is this clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
So
sir.
okay, so the basic definition you should be knowing is just that if you can be asked regarding how do you, like, it's not be subjective, but in the some of the options you can be given like left and right, that so for any function at some particular point a or 0, if the left hand limit and the right hand limit is equals to the function value itself. So if this is not equals to function value, so okay, so that's, I'll define it while discussing the continuity. So for the continuity, it should be the fa should be defined, okay. So that particular point also the function should be defined, okay. But it's not the case for the limit. Limit, the neighboring point should be defined, okay. And the most important is, for example, you have been given some fx square. So I'll just give you an example. The first example, fx equals to x square, and you have to check whether the function. You have to check whether the function is, the limit exists or not at x equals to 1. What do you think? if we'll check it for limit 1 minus and the limit for 1 plus, both are same, right? What is the value? I guess 1 only, correct?
Yes, sir.
So, and if you have to check the second example, fx equals to the float function. Have you heard about the float function?
Yes, sir.
Create
Yes,
integer.
sir.
Okay. How do you define this function? So from 0 to 1, what should be the value? 0 to 1 only, correct? 1 to
Yes,
2,
sir.
what should be the value? This is 1, 2, this is 3. This is minus 1, this is minus 2, this example is minus 3. Okay. From 0 to 1, it is defined as 0 1. Okay. From 1 to 2, what should be the value? 1, correct? So from 2 to
Yes,
3,
sir.
it should be 3.
Two.
Okay.
Yes, sir.
So, this should not be there. Somewhere this should be not be there. What do you think of from minus 1 to 0? What should be the value?
0.
0 minus 1.
-1.
Minus 1. Okay. Similarly, from minus 2 to minus 1, it should be minus 2, correct?
Minus 2.
Yes, sir.
Now, can you tell me whether the function, the limit exists at some particular point, x equals to 1? Exist or not? You just have to check whether you first
No, sir.
approach from the left hand side and then approach from the right hand side. Okay, and then check the value.
Use a limit
The
doesn't
function.
exist.
Limit does not
Okay.
exist.
Okay. Let's, for example, if you are coming from, so first you calculate the left hand limit. Okay. If you are calculating the left hand limit, we are approaching from 1 minus. 1 minus is something like less than 1, but very like that value that we are subtracting, this h is very small, h tending to 0. Okay, that's very small. Then also, we already know that if this is a float function, even though the value is less than 1, if it is less than 1, the value will drop it directly to 0, correct or not?
Yes, sir.
And if this is 1 plus h, so that means it's here. So if this is 1 plus h, then the value will drop out to 1,
1.
correct? So the function
Correct,
at
correct.
both the different points are different. So 1 minus limit, if you just check at 1 minus, the value will be 0. But if you check the limit at x tends to 1 plus, this is basically 1. And both are not equal. So for the limit to exist at some particular point, at least the left hand and the right hand limit should be same. Okay, then only you can say that the limit exists at that particular point. Is it clear to everyone?
Yes, sir.
Yes, sir.
Anyone is having any doubt in this?
No, sir. I'm checking
No,
with
sir.
everything.
Okay. Now let's move to the next part. There are some basic properties. So if you know, so for now we can be given some n number of functions also, and for individually each function, if you know that whether the limit exists or not, then you can come up with some of the properties. Okay, algebra of limit. Okay, and let's for example you have been given that the limit x tends to 0 for some function f(x), and the limit x tends to 0 for some function gx. Okay, this is f and this is z. As already we defined that the function, the limit exists for this function fx at x equals to 0. This is f, some value, some constant, some real number f, and for gx at x equals to 0, the some real number z. Okay, already
Yes,
given
sir.
that the limit exists. Now we have been asked that whether we will have to calculate that the limit at x equals to 0 at function f plus minus gx. What do you think? What should be the value? So see, algebra of limit is individually if each limit, if for each function at x equals to 0, if the limit exists, and then if you have been asked, if you are doing some algebra on both the functions, it is pretty simple. You can just do it individually also. So you can just write it as limit of x tends to 0. You can calculate it for fx, okay, and then we can calculate it for gx also. X tends to 0, this is gx. So the value should be f plus g. Okay. Second, so the same thing, if some constant has been multiplied to, so if you have been asked to calculate the limit x tends to 0 for f some constant times, so c is some constant, some real number, and then if you have been asked, you can directly do it like, you can just put the limit there directly and take out the constant. Okay, you can just do it like this also, limit x tends to 0 fx, and then you can write it like c times f. Okay, so these are all the basic algebra for any functions if the limit exists at some particular point. Okay, and you can do it for the multiplication part also. So, and you will see that there's a very like a large use of this. Okay, if you have been given something like that also, if you have to calculate the limit of fx and gx, and you already know that for both the function the limit exists at x equals to 0, so you can do it like this also, limit of x tends to 0 for fx times limit of x tends to 0 for gx also. Okay, and the value will be what, f times g.
10 0.
Similarly, yeah, and similarly you can do for the uh, like divide also. So if you have to calculate the limit x tends to 0 for fx upon gx. Okay, and at x equals to 0 for both the function the limit exists. Okay, and limit exists, and this whatever the gx that you are getting, the limit of this gx around 0 should not be equals to 1. So this g should not be equals to 0. So not be equals to 0. Okay. Then you can rather than also you can directly put the, you can use the limit on both numerator and denominator and then calculate the limit value for both the function, and you can get the final value also. So you can do it like this also for fx, and you can do apply the limit x equals to 0 for gx also, and then you can get the value f of x. Is this clear to everyone?
Yes, sir. Yes, sir.
Okay. So let's start. So we'll just solve some problem. Let's say example. We have a problem question. 5x cubed plus 0.45 x square minus 2x plus 100 by x square minus 5x plus 6. We'll have to calculate the limit x tends to 5. So you can see that you can apply the limit x equals to x tends to 5 for both numerator and denominator. You'll have to check first further whether the denominator part, because you can see that this is some quadratic equation. Okay, some
Yeah.
here
Yes,
it's
sir.
like a polynomial function. So polynomial function, for any polynomial function the limit, like any value, the limit will exist, right? At x equals to 5 you can just check it also, there will be some exact value, and that means the limit exists. Okay, you know, in the neighborhood of 5 also. So for the polynomial, because polynomial is like continuous function.
Yes, sir.
Okay, and similarly for the quadratic also, the limit will exist. So you can see that the numerator part also the limit exists, the denominator part also limit exists. So you can just convert it at like this, x tends to 5 for numerator.
And it is a property of limit, sir. Yeah.
Hmm? Yeah. Okay. Now you can see that you can apply this method. So, okay. And now you can calculate the limit. So you already know that the limit exists for this case and limit exists. And now the only thing that you have to check is if you are putting the value of x equals to 5 here, it should not be equals to 0. Because if it is equals to 0, then again it will be in the form of some real number upon the infinite. Okay. So that's, then you can't use, because we already know that, right? So this g should not be equal to 0. So the limit for g at that particular point should not be equal to 0, right? So you can see that. What should be the value? Then you calculate this. So it's pretty simple, right? Any type of questions like this, you can directly apply the limits on up like numerator and denominator both side, and then you can calculate the value of the limit. What's the value? What's the value you're getting? I guess you can directly put the value of c. If you, so individually also you can apply the limit. So you can apply the limit like this also. Limit x tends to 5, 5x cubed because you know that this x2 is a polynomial function and the limit will exist at 5. Similarly, for this quality, then plus 0.45, so limit x tends to 5 x square. Similarly, minus limit x tends to 5 of 2x. And for 100 is a constant function, so there also the limit exists, so it will be 100 only. So 100. Similarly, you can apply for the denominator part also limit of x tends to 5 for x square, then minus limit of x tends to 5 at 5x. Similarly, for limit for this constant function c 6 x tends to 5. Is it clear to everyone?
Yes, sir.
Yes, sir.
Okay. So this is pretty simple. Okay. The next method that you can use is L'Hopital's rule. Okay, to calculate the limit. Okay, so this was the one of the methods. This is very simple, but this method mostly you can apply it everywhere. That's no problem. Like problem in that. Even there is a sandwich method also that also you can apply. But to solve with the help of sandwich method, you need a lot of practice. Okay, to solve with the sandwich method. So the best
Yes,
method
sir.
that you can apply is the L'Hopital's rule. Okay, so the L'Hopital's rule you can apply it always, and mostly I would prefer you to like use that method itself so that you'll not be getting like most of the time you can solve it very easily with the help of the L'Hopital's rule. Okay, and what is
So
that
can you,
basically? Yeah,
so,
we'll start
so
solving with
can,
the
yes, sir,
yeah
can
yeah.
you write that rule so we can take the screenshot?
I'll just write it down.
Okay, sir. Thank you.
So it's like L'Hopital's rule.
Sir, it is for 0 by 0 form.
What?
0 by 0 and infinity by infinity form.
Correct. So like basically the same thing. If you are getting any indeterminate form, right? Mostly, so there are other form also, but in our course, mostly you'll be getting any function in the form of a. If you are getting something in the form of a 0 by 0, infinite by infinite, or minus infinite by minus infinite, basically that is infinite by infinite also. Same. So if you are getting any indeterminate form, like 0 by 0 or infinite by infinite. So there are other also, but that I'm not going to discuss because you'll not be getting like we are just discussing about mostly 0 by 0 and infinite by infinite. There are other infinite form also. There also you can use it, but here in our like because this is very basic course, so you'll not be getting any other form like infinite to the power 0 or something like that. Okay, so mostly you'll be getting 0.0 or infinite. So in this type of indeterminate form where you are just putting the value of that particular effect. Like for example, you have to calculate the limit at some particular point A. Okay, and if you are just putting the value, you are getting something like 0.0 and something like this form. If you are getting, okay, what you can do is you can directly use the L'Hopital's rule, okay, to calculate. And what is that basically? Is to just differentiate both numerator and denominator, okay, and that many times till the time you are getting some values. Okay. So I'll just give you an example, maybe that will help you to understand that.
So we haven't learned about differentiation.
Okay. Yeah, got it. Okay, you haven't learned about the differentiation yet.
Yes, sir.
Yeah.
It's in maths 2, I guess.
Mm-hmm.
Okay,
Okay.
sir, give example, let us see if we can understand.
Ha.
First, explain the hospital rule.
Yeah, 1 second. Okay. So So, so I told you in some of the indeterminate form you can use this method. Let's solve some problem. Let's, for example, for sin x upon x only, you can use any other method to get the limit value at x equals to 0. If you just put the value of x equals to 0 in both the numerator and denominator, you'll get 0.0 form, correct? So here you can use the L'Hopital's rule. So L'Hopital's rule, what did I say? You can, uh, whenever you're getting some indeterminate form, so whatever we have said, 0.0 and 0.5, there are other method, that other also, but that we are not discussing. So if you're getting something like that, what you can do is you can just start differentiating both the parts separately. So if you are differentiating sin x, what will you get?
Cos x.
Like, okay, so if you don't know the differentiation of sin x, basically that is cos x. Okay, okay, I'll discuss about the differentiability also. But yeah, so but if you just differentiate sin x, you'll be left with cos x. And what is the differentiation of x?
1.
1. So both will be same, limit x tends to 0. If you are putting the value of x equals to 0, what will you get?
1.
For
1.
0, 1. So now you can directly say that the limit for
Limit
this
is 1.
is equals to 1. Okay, this is simple, right?
Yes,
You
sir.
can use other method also. You can start going from 0. You can just start putting 0 plus h and then h tends to 0. Something like that also you can do. You'll get the same value, or you can use the sandwich method also. You'll get the same value. But I would ask you, I would prefer everyone to solve using this method. Okay, mostly if you are getting any problem, you'll be able to use the L'Hopital's rule, and that will not take much time. Okay, that will be very simple, and will be simple to solve it. Okay. Similarly, if you've been asked to calculate for, I don't know whether you know or not, for log something like that. If you have been asked to calculate the limit x tends to 0, to see one more thing is there are some standard function. For those function, you should stand some limit, okay, some 10, 15 that you can remember also. So you can just write whatever has been discussed in the lecture also, or the standard form, some 5, 7 has been discussed, that you should be knowing, so that you can remember also the limit for those cases. Even though for this case also, if you just, uh, so what I was trying to say is, whatever the 5, 7 standard limit has been discussed, that you should be knowing, because with the help of those limit, you can solve all the problems in the exam also. Okay, or your graded assignments or whatever the practice assignment is given, there can be some tougher question in the graded, okay, that those type of questions not been discussed, but those are just for the practices, okay. The final exam will not be getting any difficult limit that has not been discussed, okay, because there can be an infinite number of type of questions from the limit, okay, but you are not expected to know that broad, okay, you are just expected to know the basic things, and if you are knowing those basic things, you'll be able to solve. So that's why I'm saying L'Hopital's rule, most of the question you'll be able to, even the 95% of the problem, here you'll be able to use it, okay, because all the problems will be in the independent form 0.0 infinite infinite. So you can use all this in our courses. So here also you can use the L'Hopital's rule, and if you just differentiate this log base e 1 upon, so it will be 1 upon,
1.
and this is 1 again. Okay, if we'll put the value of x equals to 0, again we'll be getting the log 1 value. So this is pretty simple to calculate the limit, correct?
Yes, sir.
Yes, sir.
Yeah. You can use it for those type of questions also. Solution x plus x minus 5x plus 6 by x minus 2, limit x tends to 2. So for this case also you can use it. You can directly differentiate. You can see that if you just put the value of 2 here, it will be 0, right? You can use the L'Hopital's here. You can directly differentiate it to x minus 5 upon 1. So now you can put the value of x equals to 2. You'll be left with what? Minus 1, I guess. Correct? So this is the limit. For any function,
Sir, in this type of questions, can we cancel out numerator and denominator?
that is also one method to solve it. We can
So
use that
like
method
in
also.
question,
Let's
x
try
minus
using
Huh,
this.
yeah, you can use that. So if you are not using L'Hopital, that's the only method that will be using. You can just exclude those common part and then put the value. Okay, because you have to just check the value neighborhood of that, not the exact point.
And
Okay.
sir, how the 2x minus 5, how it is 2x minus 5?
So you are differentiating. So differentiating is dy dx of this function. So numerator part you are differentiating. Okay. So if you have 3x square minus 5x plus 6, so if you will differentiate it, you'll be left with what? 2x minus 5. Correct?
Yes, sir.
So okay, we'll discuss the differentiability. I was just discussing the limit. That's why I've discussed.
Okay,
Okay,
okay.
we'll.
So here
But then
we are differentiating separately, like separate numerator and then separately
correct.
denominator. No?
Yeah, yeah.
Yeah, that's
So
it.
whenever you are getting such a function where you're you just put the value, if you are getting something like 0, 0.0 or something upon 0, something like that. Okay, some indeterminate form where you are not able to calculate the limit directly by putting the value, then you can use this method, L'Hopital's rule. And what is that? Basically, whatever the function f(x) and gx has been given, so you can just limit at some particular point x. So you can directly differentiate it f dash x and g dash x. Okay, see, even though, let's for example, f dash x and g dash x, here also you are getting 0.0. Then what you can do is you can double differentiate it and you can calculate the limit and you can put the value of x equals to a, limit x tends to a. And here, if you are getting some value, then that will be the limit for this function also. So all are same. Are you getting me?
Yes,
Yeah,
sir.
yeah, clear.
Yes, sir.
Hmm. So for any problem, let's say a plus b to the power ex. See, and also one more thing. If you are learning, so differentiability, you will learn how to calculate it. But if you use those basic method to calculate the differentiation for each function, will be too like this is too much. So what I would ask you to, for some basic functions, for some standard functions, some 20, 30 standard functions are there. Like for example, x and log x, sin x, tan x, cot x, all those things. Okay, e to the power x. All this function, the differentiation also you should be knowing. So if you are differentiating x to the power n, what should be the value? Log x, if you are differentiating with different base, what should be the differentiation? Similarly for sin x, e to the power x. So those you should be knowing that. I am expect you to remember that somehow. Okay, so similarly for this case, if you have been asked to calculate the limit at x equals to some infinite, okay, and c plus d to the power infinite. Now you can see that this is the infinite of an infinite. You can use a L'Hopital rule, right? So what you can do is you can differentiate it with the both numerator and denominator. So if you differentiate it, this is constant, so constant by differentiation, it will be 0. Now b times e to the power x only and d times e to the power x. Okay, you are left with what? B upon d. This will be the value. Similarly, can you solve it for this limit x tends to 0, 1 minus cos x upon x square? What will be the value? Can you solve it?
It also be one.
Hmm?
It's also one. No?
This is not 1.
Also.
Just differentiate it now, both numerator and denominator part. So, see, constant if you are differentiating, that is 0. If you are differentiating cos x, this is minus of sin x. And then if you are differentiating x square, this is 2x. Correct? And you already know that this is 1 upon 2 sin x upon x. And you already know that if you have to apply some constant times some function, and this function you already know that the limit for this function is what? At x equals 0, 1. Correct? So we have solved it, right? Here, sin x upon x, the limit was 1. So this is why I'm telling you to remember some of the standard limit. Okay. So for this type of x, sin x upon x or log x 1 plus x upon x, or something like that, you have to remember all those things. So now you'll be getting what? For this, it is 1. So you'll be directly getting the value as 1 upon 2.
Yes, sir.
Got it right?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. Okay. Let's discuss now continuity and then we'll move to the differentiability part. So I guess this is clear how to calculate the limits and all the basics. So this,
Yes,
see,
sir.
if you see, if you have to calculate, let's for example, for tan x upon x, let x tends to 0. You can use a basic method also. How will you solve with the help of basic method? Tan x, just convert it into a sin x, and so this will be what? Sin x upon x times 1 upon cos x. But you already know that tan x is what? Sin x upon cos x. Okay, you have to calculate limit x tends to 0. For this function, you already know that the function value will be 1, right? Because you can apply individually, right? So for this function, it is 1. And if you put cos 0, this is what? 1, right? So this is also 1. So the tan x upon x is also 1. Okay. So you can just write it, whatever we are solving. Now tan x upon x, whenever you'll be given tan x upon, we can directly write the limit for this function as 1. Similarly, for sin x upon x also, you can directly write it as 1. See, the one thing that we have solved 1 minus cos x upon x square. This we have solved it with the L'Hopital. We can solve it without using the L'Hopital also. So each question that we are using with the help of L'Hopital, we can solve it without that also. But that method is pretty simple. That's why I told you that should be the first priority. That should be the first method that should be using. Okay. Here also you can solve it. If you have to write it, 1 minus cos x is what? Basically, if you know that trigonometry, 1 minus cos x is what? 2 sin x square x by 2. Correct? And then x square. Now you can see that if you'll just write it as sine x by 2, and then if you have to write it like this, x by 2 ka whole square. So whole together, if you want to write it as 1 by a whole square, you should be multiplying something like the what? Yeah, because it should be uh, 2 upon 4, you should be multiplying. Correct? To just balance it. And this you already know that this should be what? 1. Correct? Because if sin x upon x is 1, then you can just divide this. That is not going to make any difference, because if limit x tends to 0, then x upon 5 or x upon 2 also will tend to 0, 1. So this is 1. So you'll be left with what? 1 upon 2. So even though if you are not using the L'Hopital, then also you'll be getting the same value. Are you able to understand that, everyone?
Yes, sir.
Okay. Okay, so without using the standard L'Hopital also, you can solve it with the basic approach. But you should be using the L'Hopital to just save your time in the exam, because most of the question that has been given will be in the form of indeterminate, and you can use those methods. Okay, let's move to the continuity part. So limit is clear to everyone.
Yes, sir. Limit is pretty clear.
Okay, let's move to the continuity. And this is same, right? Like almost. So the first thing that you should solve, any function, let's for example, any function domain D to R is given as a function, will said to be continuous. This should satisfy two conditions. The first is the limit should exist, first of all. So the limit x tends to 0 plus of fx should be equal to limit of x tends to 0 minus for this function fx. Okay. And the second thing is what? This limit that you have calculated at left hand side, or this is right hand limit, basically the right hand limit should be equal to left hand limit. This is already given. And that should be equal to the fa or f0. Okay. So this two condition should be holding. Okay. For all of its domain, not at some particular point, but for all its domain, this function for so, and this 0 is basically in the domain of the function. So if you have to just tell that the function is continuous or not, you have to, for each of the particular value that is there in the domain, you have to check that. Even though for one point, if this is not holding, you can directly say that the function is not continuous. The whole together it's not continuous. If you have been asked, mostly you will be asked to check for some particular point. Okay, so the mostly the function value is not continuous at some breaking point. So if you are just plotting the curve function fx, so mostly if you would have heard, even the professor, our professor was saying that for any function that you are plotting, and if you're directly you are able to plot that function, okay, without lifting out your pen, then most of the time it will be a continuous function, okay, because you didn't lift out the pen. So from here to here, you can see that the function is continuous, and you can check the limit for any particular point. So that will be left and right and all the will be same. Okay, so you can directly say that this function is continuous. But if you are lifting up limits, for example, the function is something like that, and then you are doing like this, then you can say that because you have lifted out whenever you are plotting the function, you can say that the function is not continuous as a whole. And if you have been asked the data points where the function is not continuous, you can directly say that where this is not holding, this is not holding. So if, let's for example, this is not holding at some particular point A, then you can directly say that the function is continuous at all the points, but it's not continuous except A. So at x equals to A, the function is not continuous, because you can see that if you are coming from left hand side, the function value is this one, and if you are coming from the right hand side, the function value is this one, and that is not basically those itself is not equal. So the limit didn't exist, so that's why you can actually say that the function is not continuous. Is it clear to everyone?
Yes, sir.
Okay. So let's, for example, I'm asking one question: is the function the limit exists or not? So this is some function fx equals to mod x.
It's not a
So
quantitative function.
it's not a continuous function. What do you think, other people?
It's not a continuous function because
Exists,
it's
but
Because
values.
it's
Not a
point.
continuous.
the limit
Uh,
exists.
it's breaking, I think, at 0.
No, it's not breaking. Okay, let's say I'll just plot it again.
Continuity breaking.
Okay.
It is continuous, but it's not differentiable.
So I'm just asking about the whether the function. Yeah. So you said it right. It's not differentiable. That I'll discuss it later. But is it continuous? What did I say about the continuity?
Yes, it
I
is
just said that.
continuous.
That it is continuous.
I just said that the limit should exist. That I was just asking about for x equals to 0. So at x equals to 0, you can see that if you are coming from left hand side or right hand side, for both the cases, you can see that the function value is 0, and that is equals to exactly if you are putting x equals to 0, you'll see that the function value is 0. Correct?
Yes, sir.
Yeah, then it is continuous. Why you are getting confused in that? Okay. So for the continuity, the function, if you have just started plotting, there should not be any break in the function. So if I have to plot this, I can directly plot it, right? I can just directly plot it. What is the issue here?
Suppose,
If the
sir, we
function,
are having a domain that is from 0 to infinite. So what will be the continuity in that case? Infinite.
okay, so if the function is been given, the domain is 0 to infinite, okay,
Yeah.
then it's not, because you have defined, if you have limit,
Yeah.
if you have been asked, okay, so the domain is from this 5 to infinite, okay, and if you are asking
Mm.
about x equals to 0, then it's not defined itself, the function is not defined, then so it's not continuous at all, because you have been, the domain that you are asking is totally different, okay. So that function value, wherever you are checking wherever you are checking the continuity, that should be there in the domain. Okay, then only you can
Uh-huh.
check it.
Okay.
Otherwise, you can't.
Got it.
And again, for the what will happen for the floor function?
So this is a non-continuous function.
It's not continuous, right? Whenever we were plotting, also it was something like that, right?
Yes,
It's
sir.
not continuous. You can there's just so much of
Yes,
this.
sir.
I have to, whenever you have to plot this, there's just so much
We
of
have to
breakage in the
jump.
function. So, right. Okay, let's for example, you have been given a function something like that. So you have to tell me at x equals to 2, the function is continuous or not.
Not continuous.
Not continuous, you can directly see that. Now, if I'm asking you fx equals to x plus 1 and x square minus 4. So sorry for that, like I'm not well. So if you have to, the x value is from minus 4 to 2, and here x is from 2 to 3. Now you have to tell me whether the function is continuous or not. So in this type of problem, what will you do? You will just check where the function is breaking. So the function is breaking where? At 2. You will just check that at x equals to 2, the function value should be same. Whether you're calculating from here or here, the function value should be same. Okay, if that is not same, you can directly say that it's not continuous at x equals to 2. Are you getting me?
Yes, sir. Sir, can you solve this question?
What? Can you repeat that?
So can you
So,
please
solve the
explain
question
this?
again.
Okay, what I was trying to say there. See, this type of function, if you have been given this type of function, so that means what? There's some breakage in the function. Okay, so if this function is not continuous, it can only be at x equals to 2. Okay, there can't be any other. If like if for that you have to check. Okay, because you already know that to check whether the function is continuous or not, you have to at listen number. See, you can just make a guess that if this function is discontinuous, this can only be one point, that is x equals to 2. Because I already told you the function can be discontinuous at some if the function is breaking at some particular point. So you can see that some function is breaking at x equals to 2. Okay. So but this is not like at 2 that the function is must be discontinuous. This is not the case. Function can be discontinuous. So there can be one point. There can be only one point because the function is breaking at x equals to 2. Okay. Other point you can see that it's a straight line from -4 to 2. So there is no chance of discontinuity from -4 to 2. And again, it's some form of quadratic equation from 2 to 3 not be discontinuous. Okay. The only point that it can be discontinuous is x equals to 2. And at x equals to 2, you have to check. Okay. To make sure that the function is discontinuous or not. So to check that, what you have to do is I already told you the function limit 2 minus you have to check, and then you have to check fx 2 plus, and then you have to check f2. This all three should be equal, correct? So if you have to check 2 plus, so if you have to check 2 minus, which function value should be putting? Can you tell me the first one or the second one?
First one.
First one, because you are coming from the left hand side, and left hand side the function is defined as x plus 1, correct? So you'll be putting so 2 plus 1. And if you have to come from the right hand side, so 2 plus, which function will be using?
Second.
Second function. So this is basically 2 square plus minus 4.
2 plus.
And if you have to calculate at f2, which function will be using?
Second.
Second function, because this function is defined from x equals to 2 to 3.
Yes, sir.
This 2 and 3 is included. So you'll be putting 2 square minus 4. So these two are equal, but is this equals to 2 minus? No, right? This is not equal. You can, so this is 3, this is 0, this is 0, correct? So, so this function is not. See, the same plot I plotted here, and it said that at x equal to 2, this is not continuous. But whenever I wrote it in this form, you got confused because so so this is what I'm trying to say. Whenever you are getting, because in the exam you'll be getting this form only. Most of the time you'll be getting this type of function. And if you have been asked to calculate the number of the discontinuous point, you just have to check at the breaking point. The function can be in three forms: f1x, f2, f3. And you can be given something like x is defined from A to B, then B to C, then C to D. Okay, so at which point you'll be checking? You don't have to check at any other point. You just have to check at B and C, because at B and C only the function is breaking. So if there is a discontinuity in this function, there can be only two discontinuity, either at B or at C. There can't be any third. Like if everything is normal, like okay, so only at the breaking point the function can be discontinuous. Okay, so the maximum 2 point B or C can be the point. And now we have to check at B and C whether the function is discontinuous or not. How will you check? You just have to calculate the limit. So left hand limit, right hand limit, and at that particular point. If all three are same, you can directly say that this function if B is not discontinuous. Now you have to check for C. Similarly for C also, you have to check the three cases. And if this is fine, you can directly say that this is also not discontinuous. Is this clear to everyone?
Sir, can you scroll to the above question?
Yeah.
Sir, what if in the condition it is given -4 x is minus 4 is less than or equal to x is less than equal to 2, and in the second case also it is given 2 is less than or equal to x and is less than equal to 3, then it will be continuous.
No, if this is, we are saying that this should be there.
Yeah.
If this is there, then at x equals to 2, this function is not defined at all, right? At x equals to 2, the function 2 values you are getting, correct? This is also not like continuous. This is
Okay.
not even a defined like a correct function, right? At x equals to 2, you are getting 2 values, right?
Yes, sir.
So what's the definition of a function?
Okay.
Hmm.
Uh,
Okay. Is it clear? Can we move to the next part?
Yes, sir.
Yes, sir.
Yes, sir.
Just give me a break of 2 minutes and then I'll have a water and
Okay, sir.
okay, thank you. Okay. Are you able to hear me
Yes, sir.
now?
Yes, sir.
Okay. Okay. So we have discussed till the continuity. So somebody is asking about the difference between the limit and continuity. So I told you, right? The limit for the limit, you just have to check the value at neighbor of that particular value. If the left hand side and the right hand side limit basically is same, then you can directly say that the limit exists at some particular point. But for the continuity, at that particular point also the value should exist, and that should be equals to the left hand and the right hand limit. Okay, that's the difference between those two. There's some simple properties also. So this you can just remember it. If G is continuous at some particular point x equals to a, and f is also continuous at ZA, then you can say that then f of g x is continuous at x equals to, this like you can see that if g is continuous at x equals to a and f is continuous at x because it's already continuous at GA, correct? Because the g function is continuous at a, the function is f is continuous at GA, then you can see that the composite function will be continuous at x equals to a, because you already knew that at GA is already continuous, okay, and the function f is continuous at ZA, then it must be continuous, okay.
Yes, sir.
Again, the some basic properties for the yeah.
Can you give examples, sir?
Hmm. Some basic properties I'll tell you for the continuity also. For f and g be two different functions, and those two are continuous at some particular value in its domain. Let's for example, it's in its domain, the function f and g is continuous. So let's for example, so for both the function in its domain is continuous, then if you have been asked to calculate whether the f plus g is continuous or not, it will be a continuous function, correct?
Yes, sir.
At x equals to a. So at both the function at x equals to a is continuous has been given to you, then f plus minus z will also be continuous at x equals to a. And if you have been asked to f into z, what do you think? This also will be continuous at x equals to a. Okay. And if you have been asked upon f upon g also, if z a is not equal to 0, then this is also continuous at x equals to a. Okay. Yeah. So I'll just give you some examples. I'll give
I want to write it. The previous page.
what?
I want to add the previous page. Then we are written which is continuous and that is
I can't hear you. Which one? Which one you are saying?
yes, that's it.
This case you're talking about.
Yes, sir.
Okay.
I'm
What
just
do you want?
writing it. I'm writing something.
Okay. Right.
Sir, can you give an example for this?
I'll give you an example.
This arrange.
Okay. This example we can just for example, a function is fx equals to sin of x square upon x square minus 1. We can use the function is defined such a way that its domain is r minus 0 to r. Okay, and this is a function. So this function you can just think of as a, let's think, just think of whether this function is continuous or not. How will you think? This can be solved with a composition function. Just think of, gx as x square. Okay, and then think of fx as sin x. Then the numerator part will be what? And you have to check at what? X equals to, and you have to check at what? X equals to a, right?
Does not equal
So
to
you
0.
can a equals a 0. 0 you have to check. So you already know that at 0 this is continuous and this is continuous, correct?
Yes, sir.
So what did I say? If this function is continuous at x equals to a, x equals to 0 basically, and this is also continuous, this function is continuous at what particular point?
X is equal to 0.
This function is continuous at 0. And now if we'll just put it like this, f of g function, this is what? Sin x square, correct?
Yes, sir.
So what did I say? So if this gx is continuous, first gx should be continuous at 0. And gx is continuous at 0, right? Okay, and this function f should be continuous at what? Z0. What is Z0? Z0 is 0 only. Are you getting me? See, what did I say? If gx is continuous at x equals to a, and fx is continuous at ga, then the
Yes.
function of f of g is continuous. So I told you, right? So this function is what? Sin x square. Sin
Yes,
x square
fx and g's are continuous, then f of g of x will be
is
continuous.
continuous. Correct? So this
Yes, sir.
function, so the numerator is continuous. Similarly, you can just check it for the denominator also. So how can we are using this approach? Because you already know that this fx upon gx both are continuous. Then you can say that f upon g is continuous at x equals to a. Correct? So we are just, that's why we are checking for the numerator and denominator. In the numerator, we have used the function composition wala, that uh, properties we have used. Okay, that fx and gx, if fx is continuous at x and gx is also continuous, then you can use the f of g wal concept, right? So we have used this concept, and from this concept, you can see that sine of x square is continuous. Is it clear? Now, similarly, you can use for x square minus 1 also. X square minus 1. Here also, you can just think of as 1 and x square minus 1 is already continuous. You don't have to even use the composition here. Even though you can use it, but there is no point of using x square. So for the first case, okay, if you are not aware of, you can use the composition properties of the composition function. That if you are able to write it in the form of f of g, then gx should be continuous at x equals to 0, and f should be continuous at gx equals to 0. Okay, and if this is the case, then you can directly say that this function, the composition function f of g is continuous. Is this clear?
Yes, sir.
Yes, sir.
So
So
both
here
functions
f
should be
of
continuous.
continuous and f of g.
Okay. Yeah, so the one function gx should be
Yes.
continuous at x equals to 0, and the function fx should be continuous at gx 0. Okay.
Yes, sir.
Hmm. Because we are putting what? We are putting zx here, right? So you have to think of, if you are putting z0 here, z0, whatever the value that is coming, z0, the function f should be continuous at z0. For this case, it is 0 already, 0 only. So that's why you just have to check at fx at 0. And both are continuous, that's why sin x square is continuous. You can check it for any other function also. But yeah, let's solve one more question. So this is a question.
But sir, x square minus 1 is becoming 0 at minus 1
What?
and 1, and it is in denominator.
No, but you are checking at x equals to 0, right?
X square minus 1 is becoming 0 at minus 1 and 1, and it is in denominator. So how can we say that the domain is r minus 0?
Okay, sorry, r minus 1.
R minus 1 and minus 1
No, no,
also,
no,
right?
sorry. One second, one second. Uh, okay, this should be r minus, like 1 and minus 1 both. Correct, correct. Yeah, it should not be r minus 0. It should be r minus 1 and minus 1. Okay, yeah, you're correct. This should be not be,
Sir, I
because
have one more doubt.
at minus 1 and yeah, go ahead.
Like 1 and minus 1, this function is not defined. So is this function is continuous there or not?
It's not defined, then how can it be continuous? Can't be, right?
Okay, sir.
Because for the continuity, you check the value at that particular point also, right? It's not about the limit. Limit can exist if the function is not available at that particular point. But for continuity, you need, even though you have to calculate the limit, but you have to know the exact value at that particular point also, right?
So,
Yeah. Okay. So the limit, because if r zero was not there, how can we check it at 0, right? So that's why it should be like, that was a blunder that I was doing. So the domain is not, the domain doesn't. Okay. Okay. This is the question, and now wherever I'm doing the circle, that means the function value is not included. Okay, and wherever we are marking the dark point, that means the function value is defined here, not here. Okay, so this is the function that has been given to you, and this is x equals to 2, this is x equals to 4, and this is 10, this is 6, this is 2, now you have to tell me all this cases. The first thing you have to tell me the limit extends to 2 minus
What is
all
the
this stuff.
6?
This is the value.
Okay, yeah.
The first thing you have to calculate this. The second is limit 2 plus of fx. The limit of fx 4 plus. Similarly, limit at x 4 minus. What are the values? Can you tell me?
At limit x tends to 2 minus, it is 10.
2 minus. 2 minus is what?
10.
10.
And for 2 plus, it is 2.
2. 2 plus it is 2.
And for
What
4
about
plus,
4 plus?
it is 2.
4 plus 2, sir.
4
And 2
minus, it
minus.
is again 10.
Okay. Anybody has any doubt in this?
It is 10, sir. 4 minus is 10.
Oh, sorry. 4 minus is 10. Anyone is
sir.
having any doubt? Yeah, yeah.
Yes, sir. If first number, why is it 10? Limit tends to 2 minus fx.
Yeah, 2 minus. Just go, if you are just going around 2 from left hand side, what's the value of the function? So if you are approaching this function from this hand side, left hand side, if you are
Yes.
approaching at 2, what is the function value? What is the value of the function at that particular 2 minus? This is here, right? If you are 2 minus h, so this is somewhat here, right?
Oh,
So this
yes.
is around 10, so that's why. And if you are approaching 2 plus means 2 plus h. So if you are approaching from right hand side, that means it will be around 2, not exactly 2, but it will be around 2. So that's why the limit value is 2. Is it clear?
Okay, okay.
Sir, how 4 minus 10, sir?
Yeah, 4 minus is here. So if you are approaching from left hand side, right? So this is 10, correct?
But we not include 10.
We don't include 10, but that is what the limit is. Limit doesn't ask you to calculate the function value at that particular point. Limit just asks you if you are approaching from this left hand or right hand side, what's the value nearby to that point. So if you'll just see that at 2, if you are approaching from 2 minus h, and this h is very small, that is tending to 0. That means it's like 2 only, right? But from the left hand side. So that's why it is around 10. 10 minus some value, but it's 10. Okay?
Okay, sir.
Yeah. Is it clear to everyone? Can you calculate the limit for x square minus 6x minus 7 upon x square plus 3x plus 2 at x tends to minus 1. What should be the value? And the limit x tends to 0, x square, the same at x to 0 also. First tell me at x equals to minus 1 and then tell me for 0.
Sir, minus 8
Minus 8. Okay.
and minus 7 by
8.
Minus 8 or 8? I guess minus 8 is correct.
yes, sir,
Minus 8, it is
minus 7 by 2 another.
Minus 7 by 2 for other case. That is correct. Okay, so how did you solve? For 0, you can directly put it. For minus 1, because it was not a normal case, so you would have differentiated both numerator and denominator. Even though without that also you can solve it. You can just write it this function as what? X plus 1 and x minus 7, right? Similarly, you can write this function as x plus 1 and x plus 2. This will get cancelled. Now you can put the values. Okay. So, or you can differentiate it. So, even though if you will differentiate it, you will get the same value. Is it clear?
Yes, sir.
It's not
Okay.
clear.
It's not clear.
For 0, what was the answer?
Yes, now it's clear.
Okay. Okay. For 0, you can put the value 0 minus 7 and 0 plus 2. So, this will be minus 7 by 2.
So,
Okay. Now, the other problem that I'm giving you. Okay, I'll just try to some standard that you should be knowing. Okay, that you can't just say that this function you're not aware of. That some standard limit you should be knowing, and with the help of that, you will be able to solve mostly the questions. Okay.
Okay.
Okay. So I'll just write it for sin x. This is I guess this is simple 0. Similarly, you can do it for the cos x. For limit x tends to 0, sin x upon x. This should be 1. Similarly, for limit x tends to 0, tan x upon x. This is also 1. And the other cases are limit x tends to 0, sin inverse x upon x equals to 1. And for fifth case, limit x tends to 0, tan inverse x upon x equals to 1. Yeah, can I move forward? This 4, 5 things you should be knowing. I'm writing some more. E to the power x. This is clear. This is pretty simple. You can directly put the value. The other cases are limit x tends to 0, e to the power x minus 1 upon x. This is also 1. The other cases are this, even though without like you can directly mug up because you can get directly where you'll be using this, even though you can directly calculate it also. You can directly get it by differentiating L'Hopital's rule if you're using, or maybe with the basic approach, you'll know that you can calculate it, but everywhere you can't because if you are giving in the form of sin x upon x or tan x, if you are calculating sin x upon x itself, and that itself will take you some 1-2 minutes. So it's like there is no point of solving every time with the basic approach. You should be knowing some of the fixed limit standard. Okay.
Okay, sir.
Yeah, log 1 plus x upon x. This is also one that we have already solved it, right? Limit x tends to 0. Similarly, for this, if we have limit x tends to 0 for ax minus 1 upon x, this would be log a, basically. And the last one is pretty simple. X to the power n minus a to the power n by x minus a is n. So this thing you should remember always. Okay. There are
So
other thing also.
what you have written in 9 number equal to log x to
Log
the
a base e. Yeah.
sorry. E.
This is a. Yeah, sorry, x. Yeah. Okay, it's done, right? Can you move next to the next part?
Yes, sir.
Okay. Then solve this problem. So you have been given the function f(x) as x upon tan inverse 2x. So it's not 2x. And then b, and then sine ax upon x. So I already gave you the standard limit. Okay. Now you have to tell me this is for x equals to greater than 0, x equals to 0, and x less than 0. This function is continuous. This is given that this function is continuous at odd point. That means at x equals to 0, this function is continuous. Now you have to tell me what should be the value of a if the function is continuous. So calculate a and b if fx is continuous.
A and B both will be half.
Maybe that's correct. Yeah. Other people, have you solved it?
So for 0 minus it's half, and for plus it's also half.
That is fine. Half half. Then what should be the value of a and b? Is half, right? Everyone solved it.
Yes, sir. We tried.
Okay. How did you solve? Okay. Let's for example. So the one if it is continuous, that means the function at x equals to 0, 0 minus 0 plus at 0, all will be same. Okay. That is what you have to calculate. Okay. So if you are just able to calculate the limit for this, that will be the value for b. Correct? How will you calculate the limit for this function? X upon tan inverse 2x. How will you calculate? How did you calculate?
So you have given one formula, tan inverse x by x is equal to
And by dividing the numerator and the denominator by x, we can also do that, no?
by x or 2?
By 2, sir.
Right, so just multiplying 1 upon
2
2,
also.
right? So this is what? This is 1, correct?
Yes, sir.
Yeah.
Yes,
So
sir.
this is equals to b. So basically b is equals to half,
Half.
correct? Similarly, if you are solving limit, you have to calculate for sin ax by x also. Sin ax by x. If you just multiply what? Here also a you can multiply it here and a here,
Yes, sir.
correct? So this is also 1.
1.
So this is a. A is equals to half again because this is equals to b. So both are half. Is it clear to everyone, or do I need to solve it again?
Yes, sir. It's clear.
Is it clear to everyone? Is other people? Are you able to get it? So tan inverse x upon x, I told you, right? This is 1 somewhere, yeah. So here I told you. Even though you can use the other method also, because you are not aware of what's the differentiation of tan inverse x. So those differentiation also, again, whenever I'll discuss the differentiability, I'll just write it out, the 10, 15 important, most important differentiation that is should be known. That help you in the L'Hopital also, even for the differentiability also. Is it clear
Okay,
to
sir.
everyone?
Yes, sir. This is clear.
Sir, I'm not able to understand how sin AX upon X was
Okay, okay.
half.
So you already know that sin x upon x. This is what? 1, right? If limit x tends to 0. This is clear to you?
Yes, sir.
Okay. For sin ax upon x. So what you can do is, okay, so one thing is, if you have to calculate x tends to 0. So if you use this concept, okay, that is fine. But if without using this concept also you can solve it. So if you put x equals to 0 here, it will be 0 upon 0 form. If you have 0 upon 0 form, you can use L'Hopital's rule, right? And if you are differentiating the sin ax, what should be the value? Cos ax times a, correct? Upon 1.
Yes, sir.
If you put the value of x equals to a here, it will be 1. So you are left with a, correct?
Yes, sir.
So
Correct, sir.
you didn't get or able to understand that, right?
Yes, sir.
This
Yes,
is
sir.
a times cos ax. So ax, is it clear?
Yes, sir.
Yes,
Okay.
sir.
Or if you want to use this concept also, you can use it. See, this is what? Sine ax upon x. Correct? And you have to calculate the limit at x equals to 0. So what will you do is, you just multiply it as a here and then a here. That you can do, right? A upon a, it will get cancelled. So you can multiply it. So you are left with what? Sine ax into a upon ax. Correct? And this thing will always be 1. Because
Okay, sir.
sine, we have already discussed, is this is 1, right? Limit x tends to 0. So even though it is x or x or nx, that will be, so if we are putting x equals to 0 here, so ax will also be 0, right? And here also, if you are putting x equals to 0, then sine ax also will be 0, 1. So this is a 0, 0, so it will be 1, correct? So that's why we can solve it in this way also. So this will be 1, so you're left with a. Is it clear?
Yes, sir.
Yeah. If this is clear, we'll solve one more problem. So this portion, you'll be getting a good chunk of questions. Okay, so you can just practice it. So we have 3 core sessions. We'll practice as much as, and if you're just able to solve all these questions that we practice in the session itself, we'll be able to solve them in the exam. Okay, mostly will be as similar questions in the exam also. Okay.
Yes, sir.
Hmm.
Sir, how a becomes half?
Okay. So because a, you already calculated that for this function, you already know that this function is continuous. If this is continuous, that this limit should be equals to this, should be equals to this, correct? So for
Yes.
this case, our limit is a. For this case, our limit is b. So a should be equals to b, correct?
Okay.
And if a is equals to b, and here from here the limit is half.
Yeah,
So
got
that's
it.
why a is equals
Okay, okay,
to.
got it, sir.
Okay. Okay. So this is one question. This is simple. Fx equals to 1 and minus 1 at x greater than equals to 0 and x less than 0. Okay, and the option that I'm giving you, so the first option, limit x tends to 2, fx equals to minus 1. The second option is limit x tends to 0, the function fx is 1. The third option is limit x tends to minus 0.5, the function value is minus 1. Fourth option is left hand limit at 0, left hand limit at 0, that is limit x tends to 0 minus fx equals to minus 1. Can you tell me which of the following options are correct? Just think of and then let me know.
2 and 4.
2 and 4. I guess 2 is not correct.
3 and 4.
3 and 4. Okay. 3 is correct.
Yes, sir.
Yeah.
3 and 4.
Yeah, 3 is correct and 4 is also correct. How many of you are thinking that the second is correct?
Yes, sir.
Hmm? Everyone is convinced that 3 and 4 only is correct, not second one. And why not second? Can somebody tell me why not second is correct?
Yes, sir.
Why?
You explain
Because the
why
limit.
third is correct.
Okay, I'll explain. Let's first discuss the first option. For the first option, for x tends to 2. So for x tending to 2, the function will be 1, right? Correct? So this is incorrect option. Second option, you can see that x tends to 0. Like limit you have to calculate at x equals to 0, right? If you have to calculate at x equals to 0, what did I say? What you have to check? 0 minus and 0 plus, right? What is the value of 0 minus? Minus 1. 0 plus
Minus
1. Is
1.
this both are not same, right? So that's why this is not correct. Limit, when the limit doesn't exist at x equals to 0. You can see that, right?
So we can
Correct?
see that LHL and RHL are not same.
Correct. What about the third
Can
option?
you
Third
repeat
is
the second option? Can you repeat the second option?
second option, for at any particular point to limit to exist, what you have to check? You have to check the left hand limit and right hand limit, correct? So for left hand limit at 0 minus, what is the function value?
Minus 1.
And for 0 plus,
1.
are both same?
No.
Then
Got
limit
it.
doesn't exist. Okay. What about the third option at 0 point minus 5? What should be the value? You already know that if x is less than 0,
Minus
the function is minus 1. You don't have to check it. So, okay, now left hand limit. So 0 minus. 0 minus is minus 1. Is it correct? 0 minus the function value, the limit
that
of
is
this is
correct.
also correct. That is also correct. If I'm
So
asking
this
you
is
the right
also
hand limit, if I'm asking the right hand limit, what should be the value? The function
One.
so
value?
1.
It should be 1.
Positive, yeah.
And if I'm asking you the limit of the function, this function at 0 exists or not?
No, sir.
No, it doesn't exist,
So
right?
it doesn't exist.
Correct.
Sir,
Yeah,
repeat option 2.
option 2. So what I am saying is, for option 2 to be correct, what did I say? For any particular function, the limit 0 minus of any function should be equal to the limit of, if you are checking at x equals to 0, 0 plus for this function should be equal, correct?
Yes, sir.
Okay. So if for this function, if you are calculating 0 minus, what is the value of 0 minus? Minus 1? 0 minus is minus 1, right? If you are going to 0 minus, if you are approaching from left hand side, the function value is what? Minus 1, correct? So this function is
Yes,
basically
sir.
like this. If you will just plot it, if you are coming from, what is this? 0, right? This was 0, right? So at from, so this is minus 1. Oh, sorry. Minus 1 and this is plus 1. But at x equals to 0, the function is here. It's not here. Okay. Now, if you are approaching from left hand side, what is the function value? Minus 1. And if you are approaching from right hand side, this is plus 1. So to limit to exist, both should be equal. Is this equal? No, because
No.
limit doesn't exist, right? And that's why this option is also not correct, because it's just asking that limit at 0. It doesn't ask you if, let's for example, if this was this. Was this option correct? Second option? Now, now the second
Yes, sir.
option is correct or
Yes, sir,
incorrect?
it's
Yes,
correct.
sir. Yes, sir.
Yes,
Correct.
sir,
Now
it's
it's
correct.
correct because it's just asking the right hand limit. Okay, right hand limit, you already know that this is 1. Okay,
Okay, sir.
Yes, sir.
yeah, okay. Now the last one more problem I'll be discussing, and then I'll wrap this session today because I'm not well like it. So I'll just discuss one more
Okay,
question,
sir.
and then the differentiability I'll discuss in the, I guess, Sunday session. Okay, I'll give you some questions also to practice. If you like, you can just practice it out. So the function is the, now the fourth option, the, you just have to tell me which of the options are correct, and basically that's the limit question only. The first option is limit x tends to infinite 1 upon x is 0. Second, limit x tends to infinite 1 upon, now you tell me which of the following options are correct.
So first option will be correct because when x tends to infinity, it will be 0
Okay, what about the
and
other
1 by
option?
0 is 0.
Sir, only one correct. First.
Why not third? Third, what's the, why third is
So
not correct?
it's 1 plus minus infinity.
Yes, sir.
Fourth is
Fourth is
also
also.
correct.
Also,
So third is no, so third is not correct.
Okay, let's start. Whatever the fourth, how many of you think the fourth is correct?
Fourth is correct.
Fourth is correct, right? If you're putting, so what you can do is whenever you're getting this type of problem, you can just divide the coefficient, like x square is there, right? So you can just divide the whole function with x square. So whatever the maximum, like any variable, like for example here x is a variable. Okay, so you can just divide. You can just see that 2 is the maximum degree. So you can divide it with 2. So 1 upon x square plus 1 upon here also x upon x square, and then x square upon x square. Similarly for the denominator part also 5x square upon x square plus 1 upon x square. correct? Now you are left with what? Left with 1 upon x square plus 1 upon x plus 1. Here 5 plus 1 upon x square. Now you can put the value of infinite. So infinite, this will be 0, this will be 0, this will also be 0. So you are left with what? 1 upon 5. Is it clear to everyone? So this is correct option.
Yes, sir. Yeah.
Yes, sir. Yes, sir.
So
Get it,
the
sir.
first option is pretty simple. This is correct. Second option is what? Whatever the second option.
Undefined.
What?
So it will going to be set 0 by 1.
Whatever the third option. So let's discuss the third option first. If you are tending to minus infinite, what should be the value?
I think third is also correct. डिफरेंशिएट करेंगे तो 1/2x and then we'll put in the value of minus infinite तो वो 0 हो जाएंगे.
Okay. Okay, I guess the third is also correct.
Yes, sir, that is also correct.
Whatever the second option.
So how third is correct? Second option, sir.
Yeah, whatever the second option. Okay, third.
So second is not correct.
Why second is not correct? Yeah, can somebody explain me why third is correct and second is not correct?
Third is correct, yeah, but second is not.
Sir,
Second,
for
I think
second,
second
I
will
am
also be
getting
0.
0 as answer.
Which one? Second.
Yes, sir.
Second, when we'll like differentiate it, numerator will become 2x and the denominator will be 1. So 2 into infinite is infinite.
Yeah, so this will tend to infinite, correct?
Um,
Even though if you'll solve it with the basic approach also, so this will be what? 1 upon x square. This will be 1 upon x square. And then this will be 1 upon x. Correct?
yeah.
Sorry, this will be x square
And
upon
then
x square.
x.
So this will be left
And
with 1 upon x square and then 1 upon x. So this is
Wax.
correct, but here you are getting, it will tend to, if you are
0.
0, right? So 1 upon 0
Okay.
will be tending to infinite. So that's why it
Infinite.
is incorrect.
Yes.
Correct? And if you
Yes,
just
sir.
think of for the third option also you can just go ahead with that. 1 upon x square and then x upon x square, and this will be 1 upon x square. Correct? If you are just putting the value of infinite, what will be the value here? So this will be x square upon x square. So denominator part will be 1, right? So you are left with what?
Denominator part will be 1, but upper part will be say 1 upon x square and 1 upon x square. 1 upon x.
Correct? So
Yes,
if
sir.
you are putting the infinite, so it will be
In
tending
both
to
tends
0.
to 0.
Is it
Then
clear
it
to
will be
everyone?
0 by 1. Yes, sir.
Is it clear to everyone?
yes,
Or
clear.
should I
Now
solve it
third
again?
number is clear. No, sir.
Done?
Yes, sir.
Done, sir. Sir, will you please give us some questions?
Yeah. I'll just give you some questions. You can practice it out.
Okay, sir.
So let me calculate x and limit x tends to 0, x tan 2x minus 2x tan x upon 1 minus cos 2x whole square. So this is like really hard, okay, because we have not discussed much about the trigonometry and all. You can try it out. If you are not able to, that is also fine, okay, but I'm just giving you a harder problem so that the exam will feel like much easier will be asked, but you can try it out, okay.
Okay, sir, we will sketch our head.
What
I
हाँ got it got it. Hmm. Then the other question is, you have to tell this has been given log 1 plus ax minus log 1 minus bx upon x. This is a function has been given and it's said that it's not defined. This function is not defined at x equals to 0. Okay. What should be the value? What should be the value? The value which should be assigned to the function at x equals to 0 so that it is continuous at x equals to 0. See, this function is not defined. That means earlier it was not defined. Now you have to tell me what should be the function value so that now it is defined like continuous at x equals to 0.
Okay, sir.
Okay. Now the next problem is, this you can try it out now. Like the function isn't defined as given as
Sir, it's f of a.
f of x, everywhere f of x,
Okay, sir.
x cube plus x square minus 16x plus 20 upon x minus 2 ka whole square, when x is not equal to 2 and when x is equal to 2, this is k. Now tell me the value of k. So you can calculate this question now. This is simple. You just have to calculate the limit for this function at x equals to 2. Can you calculate it? Just solve this question first, and then on another also. Fx equals to x square minus 4x plus 3 by x square minus 1. This is x equal not equals to 1, and at x equal 1, this is 2. So this also you have to solve. Both the question, both are pretty simple.
The previous one is continuous, right?
Not like it is continuous. That's why you have to calculate the value of k.
Yeah.
And the second one, you have to tell whether this is continuous or not. Have you tried it? First one. You just have to calculate the limit at x equals to 0. Put the value at x equals to 0, no? Or differentiate it, the upper and lower.
K is equal to 0 and the second function is not continuous.
K is not equal, like I guess K is, you'll get some value, like I guess 5 or 7, I guess. If you'll just take out, no, you can solve with the help of L'Hopital also, or you just take out x plus 2 का whole, x minus 2 का whole square common. I guess you will be left with x plus 5. So that's why you'll just cancel it. You'll be left with, I guess, k equals to 7, I guess. Have anybody solved it? Tried it? Can you hear me now? I guess somehow my tab got. Hello.
You say you
Are
are
you able to?
audible.
Okay. So what I was saying is that problem you have solved it, right? The second one that is not continuous. Have you solved it?
So I don't think it.
So the second one, where the function was something like x square minus 4x plus 3 upon x square minus 2 minus 1, where you have to just
Minus
check
one.
whether the function is continuous or not. So there you don't have to do much. You just have to calculate the limit at x equals to 1, right? And you have to equate it to 2, whether the limit that you're calculating at x equals to 1, whether that is equals to 2 or not. If that is equals to 2, then it's a continuous, otherwise it's not. Okay? And you can do it, right? L'Hopital's rule, you can use it. You can just differentiate numerator and denominator, right? You'll be getting what? 2x minus 4, correct? Upon 2x. You see my screen?
No, sir, your screen is not visible.
Okay.
Now
That's
it's
visible?
visible, sir. Yes,
Okay.
sir.
So second, this is how you'll solve it. You just have to calculate the limit and then equate it to 2, whether it's equals to 2 or not, like at that particular point. So if it's not, then it's not continuous. You can see that, right? Well, you can do it for the first case. Okay, so this question, I gave you one formula, right? I gave you some standard limit, right? I gave you the limit, standard limit as log 1 plus x upon x. Limit x tends to 0 equals to what? 1. Can you solve it this now? Can you solve this? Can you calculate the function value at x equals to 0? See, I told you one thing for the sine. If you have sine x upon x, or you have to calculate sine ax upon ax. What should be the value? 1 only. So for this case, what you are able to think? So if you have to calculate this log 1 plus ax, this minus you can write it like you can write it like this 1 plus 1 minus bx. 1 minus bx or 1 plus bx? It is 1 plus bx, right? Okay, leave it 1 minus bx also. 1 minus bx. So if you're just writing like this upon x and upon x, can you calculate the function value here? Now, for this case, what should be the value? You can divide it with the a, right? A and a. You're left with what?
And
This will be a
one.
only, correct?
Yeah, yes, sorry, this will be the value only.
A. Here it will be minus. You can do it with minus b, and you can just multiply this minus b here, correct? So here also it will be 1.
Yes, sir.
So it will be left with what? A plus b. So a plus b should be the answer. Are you able to understand this? How many
Yes,
of you
sir,
have
yes, sir.
understood? How many of you have understood this question?
Yeah, understood.
Yes, I
Correct.
understood, sir.
You just
Correct.
separated it and then use that
Yeah.
standard formula. Yeah.
Correct. Correct. So and why we can separate it? Because we already know that, right? The limit, if the function is defined fx and then minus, then we can do it, right? F minus z. So all this algebra
Yes,
part
sir,
we have
yes, sir.
already done, right? For the limit. Okay.
Yes, sir.
I guess this is clear to everyone. So this is the
Yes, sir,
only
this is
question that we
clear now.
haven't solved. Yeah. So you can just solve this question. So this I'll just put it as like this. This you have to solve it. Okay. And then that we have solved all the questions. Correct? What? 1 by 2. That's
Please,
correct.
yes, sir, let me write.
Yeah. This is 1 by 2. Correct. Correct.
Okay, sir, we will solve it.
Okay. Okay, then I'll just wrap it up. So we'll meet in the next session. We'll discuss the next part. Differentiability is left, and tangent and the linear approximation. I guess then the next
Sir,
session.
on Sunday session, on next
Yeah.
session, sir, you will be our host or someone
Yeah.
else?
Anyone can be the take the session. Okay.
Okay, sir.
So and thanks everyone and for joining this in the morning.
Thank you, sir.
Thank you,
Okay.
sir,
So,
for taking class.
Okay. Thanks everyone for
Thank you.
joining this.
Thanks, sir.
Okay. Bye.
Bye, sir.
Okay. We'll meet in the next session. Yeah. Bye.
Yes, sir, get well soon.
Thanks.
Yes, sir.